Hello everyone, welcome to another interesting session of my project ideas. Today's topic is analysis of recursion. So this is our most premium DSA course and we have already covered certain videos. If you have not watched them, I'll recommend you to please go back and watch those videos and then there will be a smooth path ahead of you. Okay, cool. So let's move forward then. So most of the algorithms which you will see will have some kinds of loops or some kinds of if-else statements, cases, and many of the algorithms will be recursive. So in the last lecture, we discussed about having recursion, the time complexity of recursion, then your loops. So I know there should be a certain doubt in your mind that what exactly is recursion. So now let's have a look at what is a recursion and how do we get a recursion. We'll be studying the recursion tree also, so that somewhat will be clear to you. So many of the algorithms are recursive, and when we analyze those algorithms, we get a relation that is a recursive relation and we get a time complexity. So the running time of an input size of n happens in a function of n and the running time on inputs of smaller value. So what is recursion? Basically, it will be like a loop only, but see, somewhat when the running time of an input size is n, so you will get a function of n only when you move forward in the recursive relation. For example, you can look here, the time complexity is Tn and it is equivalent to 2Tn by 2 plus C into n. So here, this function, you got a Tn function and again, it is written in respect to Tn by 2. So the function contains n. So it's a function of n only. Got it? So for example, in merge sort, to sort a given array, we divide it into two halves. So do not worry about merge sort. We will study in our upcoming lectures. So in a merge sort, what do? It's a sorting algorithm, like it sorts the array in an ascending order. So what do? We divide it into two halves and recursively repeat the process for the two halves. So the same process is repeated for the left half and the right half. So finally, what do? We merge the results and the time complexity is written like that. And certain other algorithms that follow recursion can be binary search, tower of Hanoi. Don't worry, all these algorithms will be solved or will be taught to you in the upcoming lectures. Next, so there is another method. There will be three types of method. One I already said you, that is recursion tree. We will be studying it in the next slide also. So there are three types of method: substitution method, recursion tree method, and the master method. So let's have a look. So here what do? We guess the solution and we use the mathematical induction to prove the guess is correct or incorrect. So what is mathematical induction is, I know you, like, most of us have already studied mathematical induction when we were in 11th. Okay, so what in mathematical induction, we assume certain thing and then we prove that it is correct. So first we assume for, we write it for 1, number 1, then we write it for, we assume certain thing for n, then we get the solution for n plus 1. Okay, so here what do you for here see, for example, consider the recursion Tn is equal to Tn by 2 plus n, and we guess the solution as Tn is equal to big O of n log n. So now what do? We use the induction process to prove our guess. So this is how you can prove the induction process. This is normal maths, and when the guess is correct, your substitution method is assumed to be correct. Okay. Next, recursion tree. This is basically a bit important. So here you draw a recursion tree and you calculate the time taken by every level. What's a recursion tree? This entire thing is a recursion tree, and time complexity at each level means at this level you measure the time complexity, at this level you measure the time complexity, and in the last level you measure the time complexity. So then you sum up on. You start from a particular recurrence and keep drawing till you find a pattern, and the pattern is typically an AP series or a GP series. So it's either an arithmetic progression or a geometric progression. For example, if you consider this recursive relation, see, The last term, that is Cn square, is written here and it's divided into 2, that is n by 4. Wait a minute. Yes. N by 4 and n by 2. Here, Cn square will be n square by 16, n square by 4. So this is breaking the expression to n by 4 and n by 2. Then this will be divided into n by 16, then n by 8. This will be divided into n by 8 and n by 4. Got it? Then, if you break it down further, then you get, so because you are making Cn square, you are dividing in the terms of n square. So again, when you divide, you get to 56, 64, then 64 and 16. So to know the value of Tn, what do you need to do? You need to sum all the levels. So this level, this level, this level, sum the time complexity of all the level. So it after sum, doing the sum, you get the final time complexity. So this series has a it follows a GP with a R of, or a ratio of 5 by 16. So you get to know it's 5 by 16, and then as it is an infinite series, you put the formula En is equal to your formula, that is n by 1 minus r. So you get it n square by 1 minus 5 by 16, which is big O of n square. Because this constant term is not taken into account, you take the highest order term, that is n square. So you write it here. Okay. Next. What is the master method? It's a direct way. No need to assume something, no need to calculate a tough mathematical solution. So what do you need to do? You need to just directly get the solution. It works for the recursion relation, which can be transferred to this type. So if you can transfer, or if you can put the recursion relation into this formula, then you can use the master method. The formula is Tn is equal to AT n by b plus Fn, where a is a constant greater than equal to 1 and b is a constant greater than equal to 1. So there can be three cases. If Fn is equal to big O of n to the power c, and c is less than equal to log ab, a then base b, so your Tn will be this. For these two formulas also, your Tn is mentioned as such. So this is the master method, which is easy and you can use it as such. Then, see, this is the way in which it works. Simple, it's a recursion tree only. It's drawn in such a way. So what happens is at the end you get big O of 1 for such, and again you sum. So the height of this tree is basically log n base b, and the work done at all the levels is n to the power c, theta of n to the power c, where c is log a base b. The master method works as such. It also follows the recursion tree, but the height and the level of the work in each level we already know. Okay. Then recursion tree method is basically used to calculate the total work done in a recursive algorithm. There can be three cases. If the work done in the loops is polynomially more, what's polynomially more? It follows a polynomial function. At other levels, the total work will be dominated by the leaps. Don't worry about the leaps. The leaps are basically this part. Let me tell you what are leaps. What is a tree here. These are basically the leaps. The leaps. The leaps. This is a root node. Okay. Let's move. Yes. Then if the work done at the leaves and the work done at the root are asymptotically the same, the work done is calculated as the height of the tree multiplied by the work done at any level. So you get the work done as the height of the tree multiplied by work done at any other level. If the work done by the root is asymptotically more than other levels, the total work is dominated by the work done at the root. No brainer. So the total result is basically the work done on the root. Why? Because we always follow the higher it, the higher degree when we are writing the time complexity. So examples of certain time complexity, certain algorithms whose time complexity can be evaluated using the master method as written such. This is for the merge sort and this is for the binary sort. Okay, binary search. Then certain nodes to be taken care of. It's not necessary that a recursion of the master method form can be solved using master method. The given cases have some gaps between them. For example, so suppose this is the recursion, it can't be solved by the master method. So and the case 2 can be extended for this, because this can't be solved because this is fn function and n by log n, because the base is a function of n, hence it cannot be solved by master method. And this part also you can extend it to this. You can write it as n to the power c log k n, and for some constant k is greater than equal to 0 and c is equal to log a base b, so you can put the tn as such. Okay, the time complexity. So I hope this is clear to you. I hope the entire lecture was clear to you.